All right, so we're working on 23.2 here. It says solving problems with inequalities in two variables. Okay, this is a little bit of a longer one, and we're going to explain kind of step by step what we do and why we do it. So it says here are three situations. We're only going to go over two of them. It says there are two questions about each situation for each question that you work on. So first, we're going to write an inequality to describe the constraints, and then specify what each variable represents. And then the next, we're going to, this is important, we're going to use graphing technology to graph the inequality. I've already done that, and I sketched the graph down here. So if you would like to, you could graph it using Desmos, or you could just copy down what I have. That would also work. And it says sketch the solution region on the coordinate plane and label the axes. And then it says name one solution to the inequality and explain what it represents in that situation. And the last one is to answer the question about the situation. Okay, so the first thing we're talking about is bank accounts. Okay, it says, all right, it says a customer opens a checking account and savings account at a bank, and they will deposit a maximum, so big important thing, maximum of $600. Some in the checking account and some in the savings account. They might not deposit all of it, and they might keep some of it as cash. Okay, so what I ended up doing is I said that X is going to be equal to the checking account, so the money in the checking account, and then Y is going to be the money in the savings account. Okay, so I know that it has to have a maximum of $600. So if I add how much is in the checking with how much is in the savings, it should be a maximum of 600, right? In my mind, I hear the word maximum and I think of the inequality sign less than. So it has to be less than $600. Okay, so the inequality I wrote is X plus Y is less than or equal to 600, right? Because having a maximum of 600, if I add these two things together, has to be less than 600, but it also could be equal to 600. Okay. Again, this is just the first part. What I would then do is I would take this and then graph it on Desmos. But again, if you don't want to do that, you can just take a look at my graph here. I tried to point out all the important parts of this. So I'll zoom in here. What I did is I ended up going by hundreds every second space. I put that the checking is the X values, the savings are the Y values. Again, I put if we save $600 in savings, we save zero in checking. If we save 600 in checking, we save zero in savings. And then the solutions to all these inequalities would be anything down below here, right? You could pick any value down here to be a solution. So let's say like 200, 200 is that point right there. That's a solution to my inequality, okay? But now we can answer this last question. It says, if a customer deposits $200 in their checking account, what can we say about the amount they put in their savings account? Again, it has to have a maximum of 600. So if they put 200 in checking, I know that I have $400 available to put into my savings. So it has to be $400 or less to fit that maximum value, right? All right. So the next one, we're gonna use the same thing. We're gonna use that checking is X and savings is Y on this next one. So I didn't rewrite that fact, but we're just gonna use that. It says the bank requires a minimum balance of $50 in the savings account. It does not matter how much money is kept in the checking account. Okay, so the only thing that we're talking about is the savings account. And if we remember, Y is our savings account. So Y has to have a minimum balance of 50. Okay, so minimum means that we should have at least $50. Okay, so Y should be greater than or equal to 50. Again, what I did is I went into Desmos and I graphed this. When I did that, we had something that looks like this. Oh, trying to get this value here. We'll zoom out a little bit. Cover this up. So it looks something like this. No. All right. So again, checking is my X values, savings is my Y values. We're saying that Y is greater than or equal to 50. That's why we have a solid line here. and we shade everything above. If I wanted a solution, I would just take any point that is in the shaded region. Okay, my last question, it says, if the customer deposits no money in the checking account but is able to maintain both accounts without penalty, what can you say about the amount that's deposited in the savings? Again, it's $50 or more, right? Because we don't have any penalties, it's something 50 or more, right? That avoids the minimum balance of 50, okay? If we put in 50 or more. So the next page. It says 2 kinds of tickets to an outdoor concert were sold, lawn tickets and seat tickets. And it says fewer than 400 tickets in total were sold. Again, I would underline that. And in order to build my inequality, I would say X is equal to the number of lawn tickets and Y is equal to the number of seat tickets, right? And if these two things added up has to be fewer than 400, my inequality would look something like this. X plus Y is less than 400, right? Because this is the total number of tickets, and it should be fewer than, so less than 400, okay? Again, what I did is I went on Desmos, I graphed this, and my graph looks something like this. Again, so I put lawn tickets as my X values, seat tickets as my Y values. Again, I did that same thing where I skipped a line and put 100, skipped a line, put 200, right? I did that on both of these axes. And I graphed, if I had 400 seat tickets, we would have 0 lawn tickets. And if we had 400 lawn tickets, we'd have 0 seat tickets. I just connect these two with the dotted line because of this inequality sign. And I shaded underneath because that's what Desmos said, but also because that's where all the solutions are. That is where we have fewer than 400 seats. Again, it says, if you know that exactly 100 lawn tickets were sold, what can you say about the number of seat tickets? Again, it has to be less than 400. We already have 100 accounted for, so it would be anything less than 300. Okay, so fewer than 300 tickets of seat tickets would be sold. All right, moving on to this last one. It says lawn tickets. Lawn tickets cost $30 and seat tickets cost $50. The organizers want us to make at least $14,000 from ticket sales. This is really, really similar to some of the equations that we built earlier. What we're going to do is we're going to use that X is lawn tickets again, Y is seat tickets, and we're going to attach the price of lawn tickets to its variable X and the price of seat tickets to its variable Y. And instead of it equaling $14,000 this time, it says they want to make at least $14,000. So if 30x plus 50y, right, if that is the profit that we make, it should be greater than or equal to 14,000. Okay, again, what I did is I went onto Desmos and I graphed it, and it looks something like this. Again, lawn tickets is my X values, seat tickets are my Y values. These are the 2 points that I found that we can graph, and I would shade above my line. Okay. The last thing is you can find a solution anywhere in the shaded region. So if I use like 200, 400, that's that point right there. That would be a solution. Okay, and we have one last question. It says, if you know that exactly 200 seat tickets were sold, what can you say about the number of lawn tickets? What I did is I used Desmos for this, and it told me that it has to be more than 133 lawn tickets for them to make more than $14,000. Okay, that's a hard one, but we're going to be moving on.